So good morning dear students. After doing the standard integrals, some three standard integrals which we have done in the previous lecture, now we are heading to the next topic, that is the definite integrals. Okay, as in the starting I told you that the integration, it has been subpart into two, that is the indefinite integrals and another one was definite integrals. Okay, so now we are going to touch this topic, definite integrals, as we have completed the indefinite integral. Now let me tell you the difference between these two. In indefinite integral, we were indefinite with the answer. We used to write plus of c, no? Right? And in each and every function, you are having a function of some x, or maybe some log x, or sin x, or modulus of x. So we were getting the answers indefinite. We were not defined with the answer. But in the definite integral, we will be very definite with the integration. That means we will be getting a numerical answer or the value in this chapter, in this topic I mean to say. The very first topic, that is definite integral as the limit of a sum. So this topic is being excluded in the revised syllabus for the 2021 examination. So we won't be doing this exercise. That is, let me mention it, 8.15. That exercise is to be excluded. The second exercise, fundamental theorems on integral calculus, we will be going to see this exercise. Now let me just make you see what is the definite integral looks like. So we used to use this integration sign and fx dx, but in the definite integral we need to use the limit also here. The limit is this one, where this a is called the lower limit and this b is called the upper limit. Okay, so how do we denote this? On integrating fx, let us consider we got 5x. So what we have to do, we have to, after integrating your fx function and I'm considering that as 5x, then you have to put b and a. How you will put 5b minus 5a? That means upper limit minus lower limit. Okay, so I will with the example I will just explain you the things in the question itself. Okay, so let us take a question. Say for example, I'm taking x square plus 2 dx and the limit is 1 to 3. I need to find the value in this. Okay, so let us find the value of it. First of all, you need to integrate x square plus 2. How will you integrate this? So integration of x square will be x to the power 2 plus 1 upon 2 plus 1, x cube upon 3, and integration of 2 will be what? 2x. The limit will be going on like this. You have to write, as you integrate, we put limit here like this. Now you put 3 in this and minus 1 in this. How we will put 3? That is 3 cube upon 3 plus 2 into 3 upper limit minus lower limit. 3 cube upon 3, it can be cancelled and we'll get 9 plus 6 minus 1 upon 3 plus 2. 9 plus 6, 15 minus, take the LCM, it will be 7 by 3. 45 minus 7, 38 upon 3. This is the final answer. So the value of this function on limit 3 to 1, its answer is 38 upon 3. Now you understand what is the actual meaning of this. You know, this is a area function. How area function? Say for example, if this is your function fx in the graph and you are trying to find in this limit what will be the integration. That means we are trying to find this particular area. That is what I said. This is, we can consider this as an area function. this is for x is equal to a and this is for x is equal to b, and if this is your fx, then we integrate fx with respect to lower limit to upper limit with dx, so we'll get the whole area. As for the science student, they can understand that integration means okay, for the commerce student I can explain you that if, say for example, if this is one structure and you need to find, say for example, if this is the structure and I'm going to take a little part from it, say for example that I'm taking it as dx. Okay, so first of all I'll see the change in this particular small area, and if I integrate it, I'll get the full area. That means I can see the change in the full area. Okay, so you just don't get into this thing. You understand that it works as a area function. Okay, for every function, if we have the limits like this, we put those limit into the question and we get the answer of it. Let us do some more questions regarding the same. We need to integrate this thing. Integration 0 to 1 upon root 2, integration of 1 upon under root 1 minus x square dx. As we know, 1 upon under root 1 minus x square, integration is what? Sine inverse x with limit 1 upon under root 2. Now we write applying proper limit. What will be the answer? Sine inverse 1 upon under root 2 minus sine inverse 0. Upper limit minus lower limit. So wherever you have x, we put the limits here. So this can be written as sine pi by 4, and this is sine inverse sine 0. Sine inverse to sine self-adjusted pi by 4, and here also self-adjust. So finally your answer is what? Pi upon 4. Like this we have to do. So in this exercise 8.16, the question, the criteria, you have done those questions in the previous, in the indefinite chapter, in the indefinite topic, sorry. So you can easily integrate it. The only thing is at the end you have to put the limits, that is upper limit minus lower limit. Okay, so let us do some more questions. So for example, if you have integration of 1 minus cos 2x dx 0 to pi by 2, how to integrate this thing? So 1 minus cos 2x, what is this? 1 minus cos 2x is what? 2 sine square x. So it will be under root 2 sine x. Okay, now you take root 2 out. Sine pi by 2 minus sine 0. Root 2. 1 minus 0. So root 2 is your answer. So like that only you have to do in this exercise. I don't find any question to be a very critical question in this, because you know how to integrate, though all the questions are very easy. Okay, it is very easy to integrate them and to put the limits after it. Okay, so this question I'm doing, integration of 0 to pi by 4 tan x plus cot x to the power minus 1 dx. We can write tan x as sin x upon cos x plus cot x as cos x upon sin x. Sin square x plus cos square x, it became 1 upon sin x cos x to the power minus 1. Minus 1 let us remove, so it will be sin x cos x dx. To make this sin 2 theta, sin 2x, we need to multiply by 2, and in the denominator multiplying by 2 only. So 2 sin x cos x upon 2, so I have directly written sin 2x upon 2. Take this 2 out, so 1 upon 2. What will be the integration of sin 2x minus of cos 2x upon 2? Limit 0 to pi by 4. Now applying the proper limit, this 2 you also can take out, and this minus also, so minus 1 upon 4. What will be this will be upper limit, that is cos 2x into pi by 4 minus cos 0. As you can see, this 2 with this 2 we can cancel. Cos pi by 2 is what? 1 minus 0. So your final answer is minus 1 upon 4. So like this only you have to do. Okay, so let us do some more questions. Just listen to me. See, the questions of this type, a sin x plus b cos x upon c sin x plus d, no need of doing this question, because such type of questions are also, such type of form are also excluded in the latest ISC syllabus. In the previous lecture, I have taken some of the topics which are not included in the latest revised ISC syllabus. Alright, so no problem. We can exclude at the time of that means examination, but those forms are important and they create a logic in us. If we will exclude them, so it will be excluded for that particular examination only, but it will help you to create logic, and for the higher studies also that they will help you. Okay, so no problem, you just keep in mind how to solve those and what is the criteria, and at the time of examination you can exclude those questions. Okay, no problem in that. Okay, so let us do some more questions of it. Okay, say for example, if we are taking this question, integration of 1 to a 3x square plus 2x plus 1 is equal to 11 given. We need to find the value of a. Okay, so how we will find the value of a from here? First we need to integrate this thing, 3x square, 3 as it is. Integration of x square will be x cube upon 3, so here 3 to 3 cancel. 2x, so 2x square upon 2, 2 to 2 cancel. Integration of 1 is what? X. 1 to a equal to 11. Now put the limits, a cube plus a square plus a minus 1 plus 1 plus 1 equal to 11. This is what? 3. Take 3 that side, so it will be 14. Take 14 here, or just take 11 here only, so it will be minus of 14 equal to 0. Now after this, how you will do? You have to use a hit and trial method. Okay, because this is a cube plus a square plus a minus we don't have certain like method for finding the roots of this cubic equation, so we do hit and error. So for a equal to 1, I think it will not be accepting, because 1 plus 1 plus 1 3 minus 14, no. For 2, just check. So 2 cube is what? 8. 4, 2 minus 14, this is what? 12 plus 2 14 minus 14. Yes, so for a equal to 2, your value is coming, so your a will be equal to what? 2. Okay, so this is the final. So like that you do this exercise. Okay, so I hope you'll do, because that is a very easy. Then we'll come up with a very important topic, that is evaluation of definite integrals by substitution. So in the definite integrals, if we substitute anything, then there is a change. Okay, there we have to see some change in the limit, that we will discuss in the next lecture. Okay, so do practice. Okay, see examples. Thank you so much. Have a nice day. Bye bye.